Okay, number 3, we're given a polynomial, and we want to know how many sign changes are there in the coefficients of f of negative x. Okay, so given our original polynomial, f of x equals 6x to the 5th plus 3x squared minus 5x minus 9. We're going to plug in f of negative x. So what that means, we're going to do 6 and then in parentheses negative x to the 5th plus 3 parentheses negative x squared minus 5 parentheses negative x minus 9. Okay, so when you raise a negative term to an odd power, it results as negative. So this first term will become negative 6x to the 5th. A negative term raised to an even power will become positive, so this one will not change. Positive 3x squared. 1 negative times a negative, this one will become positive, so 5x, and this one will not. Okay, so when we input the negative x into the f of x function, this is negative. It changes right here, so it went from negative to positive, so that's one change. It stayed positive, and then it went back to negative, so there's two changes. So this is one change, and then it stayed, and then back to positive, so there's two changes in the coefficients from the original f of x to the f of negative x. Okay, so number 4, we're going to use the remainder theorem to find the remainder when f of x is divided by x minus 2. And it says then use the factor theorem to determine whether x minus 2 is a factor. Okay, so the remainder theorem says if we take this function f of x, let me do x first, f of x, and then we plug in the x value, whatever we get, that's what the remainder would be when we divided the polynomial. Okay, so this is our polynomial. We're going to divide it. It's thinking this. It's like saying take this divided by x minus 2. Okay, the remainder theorem says, okay, instead of just dividing this, you can just solve for x. So we're going to say x minus 2 equals 0. This is the process. Solve for x, that gives us x equals 2. So that's why I was wanting to plug a 2 here. So if x equals 2, whatever the remainder is, that's what we would get when we divided this. That's what the remainder would be. So this is what we're going to do. We're going to take f of 2, and we're going to find out what that is. 4, and then we're going to plug in a 2 cubed minus 11, 2 squared plus 10 times 2 minus 2. All right, so there's 2 or 3 ways to do this. I'm going to show you a couple here. One is to do it by hand. So that's going to give us 2 cubed. 2 times 2 is 2 times 2 is 4, times 2 is 8. And so I'll just do it one step at a time. This is 4 times 8 minus 11 times 4. And then we have, we'll go ahead and simplify. 10 times 2 is 20 minus 2. All right, 8 times 4 is 32 minus 44. And then plus 20 minus 2. All right, so we're going to subtract left to right. We will subtract 32 minus 44. That will give us a negative 12. And then plus 20 minus 2. So we're going to negative 12 plus 20. That gives us a positive 8. Minus 2. That gives us 6. So the remainder is 6. We can also do this with a method, synthetic division, and we can also do this with the calculator. Let me see if I can find the on-screen calculator. Okay, so one thing, I can actually plug it in, or I can just type in the function. So I'm going to show you y equal. I'm going to type in the function 4x raised to the third minus 11x squared plus 10x minus 2. All right, so if I go second graph to see the table, and we go down to where x is 2, right here, we get the y value of 6, which is what we got here. We can also do this with synthetic division. So that is, once you identify this value, we're going to list the coefficients here. It's going to be a big thing. You have to make sure that you have all of your exponents in order from the highest that's listed all the way down to 0. So we have x to the 3, 2, understood to be a 1, and 0. So we have all of our terms. We're only going to focus on the coefficients. That is the 4, the negative 11, the 10, and the negative 2. I'm sorry, I'm pointing at all this and we can't even see it. So the x to the third power, second power, understood to be a 1 and 0. And we're only going to focus on the coefficients. Okay, so I'm going to rewrite this problem down. That is 4x cubed minus 11x squared plus 10x minus 2. And we were dividing by the x minus 2 factor, which gave us x equals 2. So this number 2 is going to be my box number. And this may be confusing if you hadn't seen it before, but it will definitely speed things up and help you when you're working by hand. So I'm going to list the coefficients: 4, negative 11, 10, negative 2. The first thing we do, draw a line, we drop the first term straight down. So that would be a 4. And whatever you get at the end, that is your remainder, which you would get if you plug in. Should be a 6. You're going to multiply below the line. So times 2 times 4 is 8. Write the result up here. And then you add or subtract whatever it wants you to do. So we're going to be doing a negative 11 and 8. That gives me a negative 3. And then you repeat the process. You're going to multiply 2 times negative 3, negative 6. Combine or add these. That gives me positive 4. 2 times 4 gives me an 8. Positive 8 minus 2 gives me 6. So that's your remainder. So there's 3 different ways that we've done that. You can also do long division, which we don't need to do that here. So going back, the remainder is 6. And then the factor theorem, I think that's when we just plug it in. So what 2 ways did they want us to do? Use the remainder theorem. So all of these, any of these ways, they should give you the same thing. The factor theorem is, is x minus 2 a factor? The way we determine if this is a factor is if the remainder is 0. So if I plug in 2, so from over here, when I plugged in 2, if it ended up being 0, it's a factor. So from the calculator, from plugging it in, from doing synthetic division, all cases show you 6. So because the remainder is not 0, again, it needs to be a 0, that means it's not a factor. So is x minus 2 a factor? We're going to say no, because it's not equal to 0.